We have Manoj Pandey, and he talk about attack of Python, gotchas, and landmines in Python.
Am I audible at the back? All right, thank you. Welcome to Manoj, and this is my second talk at this conference. We're talking about attack of Pythons, so that's why I have this Python as well. So it's going to be about gotchas and landmines. So for those who don't know what a gotcha in a computer programming term is, so basically we refer to a gotcha which is a feature of programming that can actually bite you. Bite you not in a literal sense, but bite you in, it might take a lot of time for you to understand why things are happening, how things are actually happening.
So I was talking about gotchas. So gotchas is anything that can actually bite you, not in a literal sense, but take a lot of time for you to understand how things in a particular programming language actually works. So in this case, we're going to talk about a lot of Python gotchas. So I'm going to be talking about a couple of features of Python or things in Python, how they work, and I'll ask some of you if you don't know how this thing works and you want to take a guess for it. So, and most of the examples here in this presentation are being tested through Python 2. So I'm not sure about if they will actually work with Python 3 as well. But most of them should work because those features are pretty core to the programming language. Let's talk about the first thing, which is a list repetition with nested lists. So this is a pretty basic nested list. I have a two-dimensional matrix, you can see, which has 5 elements, and it is nested 4 times. And I just use a single for loop to change the list at the second index and the entire column to become 1. So let's try to do this. OK, we are done. And let's try to print it. So do you feel like this? Yeah, because I created a list with 20 zeros. I just changed one row to become 11100, but seems like everything is being changed. So what's exactly happening? So basically in Python, what happens is when you create an object, when you actually do an assignment, so an object gets created just once, you have a list, and then when you try to duplicate it, so the way this is duplicating is basically creating multiple copies to the same reference. So you might think that you're just changing the list at 2i, but it happens that all the values in the same column are being changed. So the way to overcome this thing is to use something like a list comprehension, and you can do something like this, which is the same thing. And now if I try to do this, it works. So this is the first thing we're talking about. So let's move on to the next. So how many people use different text editors and maybe Sublime, Vim, Atom, or even Notepad? So the problem is, so in different text editors, a tab represents a couple of spaces. It might be 4 spaces for some editors. It might be 2 spaces. But what happens is, let's say you're working in a team and everyone is using different text editors, and let's say a guy is there who is using Notepad, which doesn't know anything, and you probably might be using PyCharm or something like that, which actually indents everything, but you don't have the problem of these mixing of spaces and tabs. So if you have something like this, and if somebody else opens it in his own editor where a tab is basically 2 spaces, then everything will be messed up. So yeah, so don't try to mix spaces and tabs, or even if you do, make sure that you use a decent text editor which can actually resolve this problem of having tabs plus spaces at the same time. OK, so the third thing is explicit typecasting of strings. So in Python, you can actually typecast a particular string to typecast any object to any other one if there's a compatibility. So let's say if you have a float, and if you need an integer, you'll just typecast to an integer. Let's say I have a string and I want to convert it to float. That's actually rubbish. What would it get? What would you get? Definitely an error. But in Python, there are some strings, let's say INF. When you try to typecast INF, you feel something like this. Like, why is this happening? And if this is true, you can do something like this. So is infinity greater than 6? Definitely. And this is I mean, don't try to like use these kind of things in a code because it makes a lot of problems for other developers to read it. Okay, so this is actually really interesting. So in Python, I create a dictionary, and I have two keys, and one goes to Quora, and another represents Facebook. So let's create it. Okay, and so who wants to volunteer? What should be the result? Okay, how many think it should be Quora? Okay, so the rest of you know that it would be Facebook. Let's do something like this. Okay, so yeah, how many people still thinks it's Facebook? How many people think it's Twitter? Okay, so now everything thinks it's Quora. No? So actually, it is Facebook. So this is actually really weird. And I have read a really interesting article on the same thing, which would take a lot of minutes, but I'll actually try to like, reference from the exact answer to this problem. But from a higher level, I can tell you this thing. So in Python, everything is, every key every key matches using a hash method. So let's say if I use like 1 and 1.0, it will just check that if the hash of the key is correct, it will just update the value. So when I just had the 1.0 and 1, and 1.0 is going to Quora and 1 is going to Facebook, then it's actually updating the value at 1.0 and not creating another value, another key, sorry. And there's another thing with Python, Python 2, it is that the Boolean class is basically a subclass of integer. So true is supposed to be 1, and 1 and 1.0 has the same hash. So basically, even if you do something like if you do something like this, so no matter how many A of true you have in your code, every time it will just evaluate the last one, because the last line which says A1 equals Facebook is the one which is actually updating the entire dictionary. So yeah, pretty evil. Okay, so more evil is the integers in Python. So everyone knows what an integer is, right? So let's say I have two integers. One is 255, and another is 255 as well. Let's try to check the IDs. Okay, let's try to like do it. Oops. Okay. So can you see something which is pretty weird? So both of them have the same ID, the same address in memory. Okay, so let's try to like do something else. Let's say A becomes 257, and let's try to print the IDs. Now it is definitely different. Okay, so let's try something else as well. Let's say 300, and let's try to do this again. Again the same, and let's try to do something different here. Oh, it's still the same. So does anyone know how this actually works? Okay, so I'll discuss. So basically in Python, the current implementation is basically, if you have a value from -5 to 256, everything is going to be referenced to the same object. But if you have something beyond that range, before -5 and after 256, it's going to be different. So that's just the implementation, how Python is, how Python is actually implemented. So you can't do anything to it. And yeah, if you don't know about it, you can't actually guess, how this thing is actually working. Yeah, so local variable optimization, I think like everyone has done this thing. So let's say you have a variable and you have a function, and you think that you have the access to the function. You're absolutely wrong, because you're just going to get a error which says unbound local error. So the only solution here is to just just derive the variable from the globals and put it here. And yeah, and now it works pretty good. So this is actually not a gotcha, but actually just a Python trick. Okay, trailing spaces. I think a lot of people might have tried to have trailing spaces printed on the screen, but whenever you try to do this thing, Python prints it like this, but you have a way to print it on the same line. So you think that this will actually print all of the stars on the same line. It does, but there's a thing it leaves a trailing space. So basically, it actually prints the line, and instead of a new line, it leaves a space. So in Python, when it's just a print statement. But if you have to do something like this in the same way without spaces and on the same line, you just have to import the system module, and yeah, that's the only way. Okay, catching multiple exceptions. So most of the people might have tried exception handling and try except blocks. But the thing is, when you try to do something like this, I should be having an maybe here. So what happens in okay? So instead of I actually needed to print the 1 by 0. Let me change. Okay. Oh, this is actually an inbuilt. So the thing here is, when in Python, when you try to use the except statement and you need to like catch multiple errors, and you think that stating those errors on the same line, let's say index error, value error, any different kind of error on the same line, won't actually work, because in Python, the first parameter of the except should be your errors, and the second parameter should be the variable which is actually handling that particular error. So in this case, if you want to like handle a lot of errors, you need to create a tuple of those exceptions on the first parameter, and then you have to do something like this. So you can now have as many errors as you can, and you can change the function. So this is a really interesting operator. So in Python, in any other programming language, this operator is used for syntactic sugar, which basically is the same thing, but not in Python. So we think that if I'm dealing with integers and I do something like this, so it's going to work in the normal way, like it's in syntactic sugar. But let's take an example. I have a list, and okay, yeah. So I have a list. I have 3 numbers. I try to add 4 to the list, and I try to like print the memory address, which ends in 320. Let's try to like add another value, but this time I'm not going to use the syntactic sugar. I'm going to use the normal way. So now the idea is different. So in Python, what actually happens is, when you try to use the syntactic sugar method, you think that it's actually going to reference to the same object, but no. The second one, which says z equals z plus 5, which is basically saying that I have another z, which takes the z, adds the 5, and returns to a new object z. So basically, here the ID changes, and it happens like every single time, no matter in the previous example as well. Here as well, you can if you like try to like print the ID of the A every single time, it's going to be different. Class attributes versus instance attributes. So I'll actually extend this example to a couple more examples as well. So this everyone might know who are dealing with object-oriented programming with Python. When we have a class, and when we have this is like this. So when you have a class and I have a local variable, and then I have my constructor, and then I say that okay, self.a should be like 43, but inside the function I have another local variable which is like 42. But when I actually create an object and I try to like print the variable a, it's just gonna be 43 because it is actually coming from the instance, not from the class. And if I have a class variable which looks like this, I'm just going to get 42. So let's try to like extend the syntactic sugar way to have an example like this. I have a class and I have a mutable object which is a list bar, and I create my my constructor, and I do this thing like self.bar equals self.bar plus x, And let's do this. Okay. So I create one object with 42, print the value, perfect. Another object with 100, print the value, perfect. Let's try to change it. Okay, 42, 42, 100, not the same. So you can actually imagine like how this is now working, because we have already seen in the previous example. So the more complex your code becomes, even if you have those small issues with the code, it will become much harder in in the long run. List slicing, it's also really interesting. It's not a real gotcha, but Python actually doesn't actually handles this thing. So let's say if I have a list with 5 elements and I try to get the element which is out of the bound. So unlike languages like Java, where we have this out of bounds exception, we don't have anything like that in Python. So even if this is an error, Python doesn't gives an error, and it just says an empty list, which shouldn't be there. So in cases like these, when you are trying to like get something out of the bound, you just have to like make more tests. So that's the only way. Mutable default arguments. I'm actually running out of time, so let's quickly do this thing. I have a function and I have a value. I have my parameter, which is a mutable default argument, and I tried like append a value to this thing, and I print that particular value. So let's say I pass this list 1 to 3. It's going to be like 1, 2, 3, and this value. Then if I have another list like with 1, 2, it's going to be 1, 2, 2, 2. And then if I try to like print x, it's going to be like 1, 2, 2, 2, because that's what x was. But this was expected. But let's say if I just try to like call the myfunc value. So it does work like this. Because in Python, when you create a function, everything is like instantiated at the same time, just once, that's it. Otherwise, I mean, the next time it's not gonna do the same thing. It's not gonna have that empty list. It's gonna just overwrite again and again. So in cases like these, when you have a parameter and you don't want to, I mean, you have a certain kind of requirement like this, try to accept the parameter as none, and then you can just check if the value is not none, then you can actually move ahead. Okay, string concatenation. Okay, you can just see. This is also based on the previous example as well. So let's say just focus on the line s equal s plus this string, and then z dot append. So append is a method in Python, and the plus is basically doing the same thing and of creating a new object. So if you like time those functions, which are actually doing the same exact thing, the first function is taking like 23 seconds, and the second function is just taking like 0.3 seconds, which is huge. Like the first one is taking huge time. So yeah, don't try. I mean, try to like minimize these kind of things in your code, which would make your life easier. This is probably a really famous question when you have a tuple, and we know that tuples are immutable. And if you try to like do something like this, which is like what, and definitely will give you an error, which is like type error, which is correct. But what do you think? Like, what happened to the tuple? Like how? So so with tuples, you don't try to like do this thing. This is this is a problem with Python internally. I think I saw on the mailing list, I saw a discussion about this thing, but you just have to like use the append method. So make sure that you use the appropriate functions with the objects, with the Python objects. Okay. Yeah, so in Python, it's a really good advice to ask for forgiveness than permission. It's just like don't try to use a lot of for loops, if loop, if else, just do it. And let's say if it doesn't work, you can always expect some error. So that's the way, that's more of a Pythonic way. So the first one is not actually advisable, but the second one is actually correct. So yeah, it's just a small advice, and there's a link to a really nice small documentation about the best of the best guides about this Python, writing more Pythonic code. So yeah, you can have a look. I'll actually give you the link to the slides as well. So yeah, thank you. That's it.
Any question?
So how many people actually knew one or the other thing? Like, I think like the tuples was a pretty common example. Yeah, Ray? Okay, yeah.
I was just saying that I knew one of those examples.
Yeah, yeah.
Have you run into any of these yourself in your own code?
A lot. The default arguments, a lot. I mean, I know every time that I don't have to use it that way, but it happens all the time. And there's another gocha which happens a lot when you actually try to copy like a JSON or dict, a large dictionary, and you try to like create a copy of a particular dictionary that you have, which has a lot of data. Let's say you're dealing with some Twitter data mining, and you get lots and lots of data, and you try to append it, and finally, you think that your data would actually replicate, but it doesn't happen. And still now, I haven't been able to like figure it out, but the only solution that I've figured it out is to use deep copy. I'm not sure, like a lot of people might have also run in the same thing problem, but yeah, so like the default argument and the deep copy thing happens a lot with me. Okay, yeah.
Anyone else?
Thank you for the talk. I really enjoyed all the things that I've seen cause me pain as well. My question was about your awesome scarf, actually. Where did you get it?
So the credits to this goes to Mirko, who's sitting on the front. He got it from FOSDEM, I suppose. Is it correct? Yeah. I think like we should also get this thing to a lot of people. Love it. All right. Thank you so much.
Thanks.